Stored in one class. Yeah, tell me.
Okay.
Yeah, Devi.
Yeah. I will ask. Yeah, I sent you this function. Uh, I mean, here we can use like and also we can use. I mean,
I can see the function. Okay.
uh, okay. So I want to how I can here we select some. I mean, all the columns are coming. So I want to select some particular columns, two, three columns. How I will do that one?
So the selection you have to done here,
Yes.
right? This data frame, whatever you to top 5 columns, bottom 5 columns, based on certain filters, you'll be doing it here. On top of that, you'll be applying this. Got it, right?
Yeah, actually, I mean the loan file having all the columns. I mean, suppose 10, 20 columns are there, plus it will added with the one column like loan amount concat CAT.
Uh-huh.
This is one extra column added. So I want only loan amount concat and loan amount, two columns I want. How I will do that
So you have to do this thing on a data
one?
frame which is filtered content. Okay, you have first you think, then you do this, then you try to make there, and of course you'll get only that part of the filtered data frame. First you have to do
Mm-hmm.
filtering, then you have to do transformation. Got it, right? This
Okay.
is a transformation API. Like what you're trying to do based on these values, you're trying to change the values here, right? Map is a transformation API. So transformation you should do on filtering.
Okay.
You can do the other way, but after transformation, if you are doing filtering, you're unnecessarily doing transformation on certain data, isn't it?
No,
Filter.
no. Actually, someone's I mean, client requirement, somebody requirements only two, three columns. Then if they don't need all the columns, so on that time, what you will do?
If you have to do it, just a second. Yeah. So if you are doing some selection on certain columns, first filter that. Okay, maybe I can show with an example.
Yes.
So it's visible from there, right? Or do I want?
I mean, the font size is very small. It is not visible properly. One second.
Should be better now, right?
Yes.
So here, suppose you have this data 1, 2, 3, 4. 5, 6, 7, 8. Okay, so this is how your data frame looks like. What you want to do is you want to, you want to multiply 2 to only these columns. In a column, whichever data is multiple of 2, you want to apply, you want to multiply b into 2. Otherwise, you don't want to multiply. Got it, right? You are doing selective operation here. If you're asking this way. Got it, Devrasa?
Yeah, one second.
Okay. So, so here, what you can do is df. You have, I mean, to do these things. You will learn to apply, right? If you have to do such complex operation, so pass the def function here and access1 def f row if percentage 2 into 0 return b into 2 else okay, now if I do this, see here.
Okay. In this case, I want only a then new. So what I will do?
Right, you can see, huh?
I need the a column and new columns.
That way
Column.
decide. You can do this. Got it?
Yeah. Oh, thank you.
Okay, or you can drop also. If you want to drop a column, how do you drop a column? Df dot drop. Sorry. So you want to drop column D, access1. It will drop that column. And if you want to permanently drop it, you have to write in place is equal to true. Makes sense, right? No, by default drop, nothing is permanent. Okay, but if you want to make it permanent, you have to do this in place is equal to.
I wonder one more question. Last time we did that. One second. That scatter we did. So on the scatter having, sepal length, sepal width, pattern, and these things are there. Okay. So
Right.
with the scatter, the scatter is from different color. I want to give sepal red color and sepal length is yellow color like this. Can I do that one?
Yeah, you can do that.
I tried, but it's.
Just see the color options. You have color options in Matplotlib. Okay.
Yes, in Matplotlib having colors. I checked the red, yellow, all colors are there. But I get the color equal to red, something I get. But some
It's not
error.
working, huh? Okay, so what will I do? I'll anyway do plotting for various other options. Okay, so because I have to create some data and all that, so I'll show it there itself. Fine, right?
Okay. Okay.
Okay, so anyway, plotting, just keep remind when I do, just remind me once. Huh?
Yes. Yes. Yes.
Okay, so okay, so now last time we have done this. I mean, we were planning to do box plotting. Okay, let me show what box plotting really means. Okay, box plotting is to understand the distribution. Box plot. Okay, so import. So the idea is how to understand the distribution. We started with probability mass distribution and all that, right? So import.
And yeah, the font size is a little bit. Can you make it large?
I think you are not zooming the entire screen. There is something. Just check some options because generally that's the thing.
Yes, actually, white means it's visible properly. Black, that's why it's not visible.
Oh, I thought reverse. Okay. Okay, it's fine now, right?
Yeah. Yeah.
Okay, so this is known as box. Okay, box plot. It is to show you distribution and all that. Import. Import. Matplotlib lib spelling. Okay. Ad dot import pandas pd np brand int 1 to 10 generate 100 numbers. Okay, this is one data. Df1. Okay, so if you have to do box plot df1 dot a, you can see this box plot coming into picture. Got it, right? This is telling you this is the lowest value, this is the highest, the rest of the numbers here. Change the color. So you can see here. Okay, so you can see here, this is that particular column and this is the range of distribution. Between 1 to 9 the values are. Okay, this is the lowest value, this is the highest value, this is the 75% of the value, this is 25% of that, this is the mean of the value. Got it, right? If you do df1 dot describe, you get the same stuff, right? You can see mean is something around 4.88, so it's little less than 5. Okay. Okay, so little less than 5, and then you have this guy here, 1. This is the lowest value. This is the standard deviation 2.5. You can see mean is there, right? 25% is 2.7. So this is somewhere around 2.7. You can notice this, right? It is not 2.7. Understood, right? How to understand box plot. So you can plot your data kind of anywhere here. It can show you the box plot thing here. You can actually do for multiple columns also. That's the best part. If you want to really understand the distribution of some data. F capital data frame. F capital. F capital. Do tab, right? Use tab. Don't write completely. That will be error prone, right? Yeah. Yeah, not right. Okay. Still not getting blocks. I'm not getting. Do down. You have to do for box plot. You have to do right. PLT dot box plot. PLT dot box plot. Tab. Yeah. Okay. Write the column name. If you have multiple columns, what do you know? K2 9 K2 9. DF1 A, DF2 B, DF, DF1. Why is this now? Should follow the series is ambiguous. Oh, whenever you are giving it here, right? One thing you have to do, you have to pass this as a list, not as a separate element. Yeah, got it, right? And of course, you don't want to do that plt.show. All right. So this is first column. This is the distribution of it. This is the second column. This is the distribution of it. For each feature of a table, we can plot something like this. This will tell you the distribution of the data. And if you do df describe, you'll find both for both the columns. Right here, you can see this guy's mean is 5.3a. This is the mean 5.3. This is actually, yeah. Okay, here the minimum value is 3, maximum value is 8, 50% value is 5.5. This is the 50% value, 5.5. Here, yeah, 50% value is 6. Right? This is actually 50% value, not the mean. Okay, this is a 50% value. This is where the 50% data lies. 50 percentile of the data. So if your data, if you, whatever your data is, like suppose it is 4.7, you can realize that it is less than 50%. Right, got it, right? You'll understand where his data is localized. That is the information.
Second one. That green, orange color, it is a standard deviation.
No. That is your 50% of the data.
50%.
50 percentile of the data. Like, you know, if you see 25 percentile of the data, that is for this guy it is 3, and the percent for this guy it is 4.
But here for me it is not 50%. It is
I mean, it's random number that you are generating, right? Depending on the random number generation.
Okay.
Got it, right? So it might be different from everybody.
I have a doubt. This plot function we can use using both PLP, and is there a plot function for Pandas also?
Pandas plot function is also there. Okay, if you have to use that, I think last time I was using few of them. Like you can do df1.plot box. Here you have all the options here now. Box plot is not here, right? But you can directly do this box. Got it, right?
So like which is better?
Doesn't matter. Up to you. I mean, functionality wise, there is no set performance distance and all that. If you have a data frame and directly want to do some plotting, you can do that. Got it, right? Part of box plotting. Okay. Then the next thing is exponential distribution. Exponential distribution. Okay. So what is exponential distribution? The exponential distribution is 1 minus. That means exponential graphs are there, right? They can show something here. Exponential distribution. Okay, I'll show the graphs, images. You see this? Yeah. This is exponential distribution. Oh, sorry. Exponential distribution. Got it, right? So if your lambda increases, see this is lambda is equal to 0.5. So this is how the curve is. Lambda is equal to 1. It's getting more steeper. Got it, right? If it is lambda is equal to 1.5, it gets more steeper. These are exponential distribution. That means any feature, if you are plotting, it gets plotted this way. This is the value of it. right? This is your exponential distribution.
But one thing I didn't understand. But lambda is 0.5, right? But the orange color line is ending above 0.9. But it is showing 0.5. How it is?
I mean, from lambda, how is this value getting executed, right? That is 1 minus e raised to the power 6 lambda. Okay, if you see exponential distribution functions, just note the graph, and that's what I want to show first. Okay. Then I'll show you the function of it. Okay, the reason is exponential distribution function.
The graph is just for example.
Right. Okay. I'll just show the formula now. Okay. So you can see here, this is one of the exponential functions. Okay, if you have to draw it, wait. You will write 1 minus, where is it? Okay. You basically would write like this. CDF function is 1 minus e raised to the power minus lambda x. Exponential. So what is exponential curves? It will curves like this, right? 1 minus, so it is like this. Okay, these are exponential distribution curves. Okay, so you have various terms here. Okay, you can see here mean. Okay, this is mean of the data. This is probability distribution function. You remember what is probability density function? Probability density function was, see, we started with histograms, right? Histograms means the frequency distribution function. If you divide, if the frequency you are dividing by total number of occurrences, that will tell you how much time probability of that particular data, isn't it? If it is, got it, right? So if it is normal distribution, after that it will be a bell curve, because the probability of middle elements was very high. Got it, right? That was the case. That was your probability density function. That means middle data, see 50% of, remember we had this discussion, 50% data is a probability distribution function. Now again, you have this cumulative distribution function. Okay, so cumulative distribution function, right? Okay, so what it is doing, it is actually, this is your value of x, this is your value of the outcome. Okay, and what it is doing, it is actually plotting you cumulative distribution of the data. Okay, what is the distribution of the data? And if the distribution of data is like this, that is what you are saying, you say the distribution is exponential. That means if what does it mean? If there are a lot of data which are very high, there are a lot of data which is very low. In the middle, there is very less type of data. Okay, if you plot income these days, right? Income is, I mean, if there are a lot of people rich, okay, a lot of people rich and a lot of people poor, the income distribution will become exponential distribution. Okay, there are certain, if you plot certain data, you'll always find them not to be like this. For a lot of algorithm works well if it is normal distribution. If you plot the data, it might show you, start showing symbol like this. That means lot of values, the value is actually very high. For few values, the value is actually very low. You can understand the difference between this and this. This is much more, this becomes a sigmoid curve. We'll study later. This becomes a exponential curve. This is one another curve. Okay, these are your exponential distribution. This was your CDF. CDF basically tells you what is the, like, that is what cumulative distribution function, right? CDF is a real valued random x or just distribution. Yeah, nothing much more is there. Okay, I got a hang of it. Distribution. Okay, now there are a lot many other type of distribution. We saw this exponential distribution one. The other one is normal distribution. Normal distribution we understand well, right? It's a bell curve. Okay, so exponential distribution is done. Okay, normal distribution is done. Now, what is the mean of? If the normal distribution mean is 0, that means that is known as standard normal distribution. Understood what I'm trying to mean? Trying to say. What I'm trying to say is. Okay, now what we have seen here is, suppose suppose this is 0, this is -5, -3, understood, right? +3, +5. If the curve is like this, right? The mean is 0, isn't it? Okay, and the mean 0, that is known as mu is equal to 0 and sigma is equal to 1. Then it is known as standard normal distribution. Got it? Normal distribution. This can be a normal distribution, right? But if it is like this, it is standard normal distribution.
What is it? Mu and sigma is it? Mu and sigma, right? What it represents?
Mu means median. Sorry, mean. Mean means sum of the data divided by number of occurrences, right? Mean is 0 because a lot of half data is negative, half data is positive. So mean will be 0. And standard deviation is, you remember what is standard deviation? Standard deviation is square root of variance. Okay, this is the formula for standard deviation is equal to I is equal to 1 to m x I minus x bar whole square. And this is square of standard deviation. So square root of this is known as standard deviation. Yeah, I have written it, right? This is known as variance and that is known as standard deviation. So remember, CDF of standard normal distribution is 0.5. Okay, so let me see more. Just get a hang of the distribution. Then there is log normal distribution. Log normal distribution.
CDF mean is 0.1, right? 0.1
CDF of it's this standard normal function is 0.5. Okay, these are the online stat books also you can refer. Just I gave some pointers around it. You can refer that. So let me go to a much more interesting topic. Okay, last time we have discussed scatter plot to understand relationship between the data, right? Scatter plot. Okay, so plot X and Y, and we found out that I is data, different columns to understand relationship between data. Then one more thing that I have to discuss is correlation. What is correlation?
Is matching the results between test and
See, we have this thing, right?
Comparing the results, actually, correlation is.
Yeah, I mean, we all understand the English. I mean, when we say, but say in your data, this is your data. Like there are multiple columns. Okay, so there are multiple columns. That is your A. Okay, these are your multiple columns. Okay. Now, as far as multiple columns is concerned, sometimes what will happen, and say this is your different features, right? Remember we discussed what are features of the data. Features difference age, gender, and finally, one column will be there like income. Based on other column, you're trying to predict one column that is possible, right? So these are known as feature columns. So correlation, is a, correlation tells you how much this column A is related to column B. Understood? Correlation. So correlation basically tells you what are the correlated features. Means if this changes, this also changes. Got it, right? If this does not change, this also does not change. Like, there is a strong correlation between, feature data, income and tax, isn't it? Because income increases, tax also increases. Clear? Okay, this is known as correlation. Okay. So there are certain ways. Okay. So why do you think correlation is important understanding in the data set? Understood. Suppose you have a data and you see two columns are showing strong correlation. Why do you think that is important? I mean, why do you think understanding that is important?
So we can predict one variable if the other variable is strongly correlated.
Absolutely. That is first point. That if your target is correlated with feature, remember these two lines are very different. What you're saying is target correlated with feature. Okay, that means if you change the feature, target will also change. You are finding very important. This is a very important critical column in predicting, like lifestyle is expenses directly proportional to income. Okay, to a great extent. Okay, so okay, now that's one thing. Okay, understood, right? If your feature and target, if the two features are correlated, then what is the impact on the target? You spoke about one feature and target relationship. Now, when two features are correlated, what is their impact on the target? Okay, it might have double impact. Got it, right? If two features are related to target, you don't need to consider both of them, right? You can suffice with one of them, right? So this is we'll discuss that when we use that. If there are two columns like income and tax are there and predicting lifestyle, you will not use both of them. You might end up using one of them. Got it, right? Okay, so that's the important point. Okay, now so there is a function which tells you correlation. Suppose in Pandas, let me create a data frame. Import Pandas as PD. PD dot data frame This is A. 1, 2, 3, 4. Five, 6, 7, 8. Okay, so this is CDF, this is DF. No, DF.co. If I do this, so what are you getting? A is heavily correlated with B. 1 is the highest value. Understood, right? A is correlated with B. Now, if I change this value here, I'll just, for this time. Now my correlation decreases here, isn't it? See, because the one guy is totally messing up. Understood what is happening? So correlation means positively correlated means if one increase, other will also increase. Negatively correlated means if one decrease, other will increase, right? And so if you're plotting this data, you basically plot it like, you can see A and B are negatively because the last value, if you increases, last value is decreasing. Just make it closer to that. See, it improved 5. It's getting closer to this, right? 9.9. And finally, when you make it 8, because all of them it is increasing. So you realize that, these columns are heavily correlated. Okay, now there is something. Sometimes what happens, right? Sometimes if you have this, not in the same scale.
Avantika, meeting will expire within 1 minute.
Oh, okay. Okay, let me send the link.